All right. So now we have discussed what is machine learning. We have also discussed what are the components that are required for a machine learning problem. We looked at inputs getting supplied to an algorithm which outputs either a pattern or a prediction. Now, this is a sentence that I will keep repeating and keep showing you more in terms of diagrams and pictorial representations because it becomes more simpler for you to apply if you kind of think in that way. So this is what is machine learning all about. Then we also looked at what are the tools that we can use for machine learning. We particularly discussed installing a Python distribution called Anaconda. And before we go ahead and actually start writing some code and start looking at some example, let's go one level deep into these algorithms that we have been referring to. So I will go ahead and show you what these algorithms are comprised of. However, my main intention of this course is not to go deep into statistics, right? So maybe I'll devote a separate course for it. I will, however, be providing you with some additional reading materials in case you are interested in learning more about actual statistical concepts. All right. So without thinking too much, right? If we just look at this particular diagram, what we see is four main words that stick out, right? One is classification, one is regression, the third one is clustering, and finally we have dimensionality reduction. So this is a very high level way in which all the machine learning algorithms are categorized. So depending upon what problem you are trying to solve, we will choose one or more algorithms that belong to these categories. So you see words like samples greater than 50, then you have category, more data, and so on and so forth, right? So we will keep revisiting this diagram as we move forward. Now, let's take a very simple data set. So your problem statement is use machine learning to predict profits per sale, right? So now we are trying to introduce a little bit more nomenclature into this, right? So we're going to call these inputs as features. Okay. Now let's assume that your input looks something like this. Very, very simple, right? So you have sales, it says $30, $40, $50, $70, and you have the corresponding profit, which is $3, $4, $5, and $7, right? And sales, we are going to, maybe call it as uppercase X and profit as lowercase y. Now don't worry about why I'm calling it uppercase X and lowercase y. We will cover that in detail in the next lecture. Right. So now just imagine that, you have this input and output, and like we have been discussing in all our lectures, we are going to give this to an algorithm, this whole table, and let it study the patterns, right? So that if a similar input comes in the future, it can predict that output. Right? So how will this look like? So if you supply this to machine learning, it will output y. Actually, this should be small y. Y is equal to 0.1 times x. Right? It's very simple, right? So if you see, 3 is 0.1 multiplied by 30, right? And this is what is machine learning, right? This is what the machine learning algorithm will do. Think about it. See, this is how the output looks like, right? 3 is nothing at 0.1 times 30, which is, the profit. Similarly, 4 is 0.1 times 40, and so on and so forth. Right? So since now you have the model, now what I mean by model is this particular equation that you see, this is the machine learning model. So when you actually get a statement like fit a model, right? The model is nothing but y is equal to 0.1 times x, right? What it says is, if you actually give an input in future, any value for x, the y value that you get is your predicted value, right? So let's look at it. So let's assume that if the input was 100, right? The sales input was 100 and no output was given, can you predict the output or can you predict the profit? Well, you can, right? Because you know that it is 0.1 times the sales. So the profit will be $10, right? So this is what we are going to do in this whole course, right? Well, we are going to kind of look at some algorithms which can ultimately give us an equation. And what we're going to do is we're going to supply some inputs to that equation, and that equation is going to spit out an output, right? Now, remember, I have taken a very, very, very simple example, right? We only see one input over here. In the coming lectures, we will see how to take this input in Python and supply to a machine learning algorithm and look at the machine learning model, output, equation, however you want to call it, right? So we'll look at also how to choose an algorithm and how to deal with multiple inputs. You have just one input here, then it's in most of the machine learning problems that you will get multiple inputs, right? And we'll also look at some techniques on how to evaluate if your predictions are indeed correct or not, right? There is plenty of ways in which you can do that. We will study that. We'll take little part of our given set of data, train it, and then try the same into predictions and see how close it is to our actual value. So we don't worry too much about it. We'll take that step by step. So having said that, below are some of the commonly used machine learning algorithms. So if you are a starter, this might be a little bit overwhelming, but if you remember, I promised that we've been always dealing with some inputs going to an algorithm. We looked at what are the categorizations of these algorithms. We looked at those 4 categories, and now we're looking at actual algorithms, right? So again, if you're a starter, I would suggest start with some simple example inputs, see what output you get from these algorithms, then decide which algorithm gives you close to the correct prediction. Remember, machine learning is not magic. It's just simple statistics. Your algorithm's correctness and output will highly depend on your inputs. The trick in machine learning is to choose the correct set of inputs and supply to the correct machine learning algorithm, which will give you as close as possible to the correct prediction or the correct result, right? So these are the 2 main categories that we discussed. And supervised is nothing but you supply input and output to the algorithm and let the algorithm study the patterns or the relationships between the two, so that if a similar input comes in the future, it can actually classify or categorize and predict the output based on what it studied before. So commonly used are your linear regression, logistic regression, we have classification, decision trees, and so on and so forth, right? Then we have a couple of unsupervised algorithms as well. Again, don't worry too much about it. For now, we will take a few examples, take some actual data, and use Python to actually show how to supply that to, say, a KNN algorithm, right? K nearest neighbor algorithm, and how can we get the output and how can we study the output. Again, we are taking it slowly, adding step by step, so please bear with me here. Again, there are a lot of terms that I introduced in this lecture. I would suggest that you do a reading of these things. And again, as I mentioned, this is not a statistics course and this is not a Python from the scratch course. So you have to do some reading, but I will try to keep it as simple as possible. I try to explain just the minimal things that would be required in order to kind of get your feet wet and, get started. But I would strongly suggest that you just give a brief reading about these things that I have mentioned in the additional reading. That will at least prepare you well for the next lecture. Thank you so much.